Okay, now start recording. Share the screen. Okay, so last session we were at chapter 13, and today I'm gonna go to the chapter 14. You please use the textbook that I mentioned, this one, as the note that you should go back and read this one. Yeah, go along with it. This one, okay. Chapter 14. It has several examples that you may want to look at closely, because I think it's going to be part of your exam soon too. Okay. 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 On this chapter, you will learn about how to estimate the speed of a basic freeway or multi-lane highways under prevailing conditions. Okay, and you'll be able to calculate the flow rate and the density of the segments, and also you will be able to understand and use the passenger car equivalents for trucks, buses, and RV on the specific grid. What RV stand for? Anybody knows? RV stand for recreational vehicles. So the recreation vehicles normally seen in the US, not in Europe. But so anyway, I'll show you what it looked like for the RV.
มันคือรถบ้านไหมครับอาจารย์
ใช่ครับ recreational vehicle. So yeah. So some of these trucks or RVs are very expensive. You can stay and travel like a house, and you can cook in anything. However, the maneuver capabilities of these vehicles are quite difficult in some road because of their sizes, and the power of them is heavy. So, but it's quite popular in United States, especially for those who are older than 60 years old. When they got retired, they sold their houses or their properties and get into these vehicles and travel across the country. That's why we got to understand the impact of it. Anyway, let's come back here. So yes, trucks, buses will get the impact of grades, of course. So steep grades will give uh, the impact to lower these vehicles down. But for the downgrade or downhill, these vehicles maybe have less impact. But for the long distances, um, heavy vehicles may contribute to uh, difficulty of maneuvering, make it um, make the safety uh, get some adverse if they cannot brake in time. Like some part of our countries, like the Route 304, that strength from Raminta to Korat. This straight route passed through the area of national park, and the grade is quite steep nearby this national park. Um, some unfamiliar drivers who drive buses or trucks who never got the experiences of driving on steep hills normally end up getting into an accident in this route. So according to our engineer, according to our role as an engineer, we should actually avoid to design the roadway that have got the great uh, impact to those vehicles that much. But our problem is that because it's passed through the national park, um, the national park has some limitation of expanding or widening the road. So we cannot really make a good design that will accommodate to commercial trucks, buses, and so on. So according to those limitations, we still have got the same, we still have got the problem once these trucks or buses coming downhill. Okay, in this chapter, we focus on two broad types of these facilities. Okay, one is freeway, the other one is multi-lane highway. On the left corner, top one is the image showing that this is a typical 8-lane freeway. So 4 on each direction. A divided multi-lane rural highways look like this. When we say divided, there will be always a median, either the rest median or a concrete barrier median. In Thailand, we will see depressed median too. Depressed เกาะร่องนะครับ For picture C, this is a divided multi-lane suburban highway. Yeah, you shall see some modernizations, like factories, commercial stores, those type of things. But it's not as dense as in the city. Okay. Picture D, picture D, picture D, this is the undivided multi-lane suburban highway. So when we say that undivided, it's just a strip of pavement marking that divide the highways. Multi-lane highway with two-way left turn lane, TWLTL. Okay, this is not typical for us to understand because we didn't in our road system we never had this kind of two-way left turn in the middle of the road. But we will see what we call SCOTC as the most similar to the TWTL. I show you what does it look like for the lane. Two-way left turn lane. Okay. Okay, this may be the what you see on this graphic. This is what I mentioned about two-way left turn. This street has 3 lanes, one for each direction, and the middle one contains two-way left turn lane. For those who want to enter to premises, parking lots, on your here, this is a Starbucks, I think, store. You're supposed to be on this lane to make a left turn. What is the benefit of having this two-way left turn? What do you think? So you may see the movement like this, right? So a vehicle that want to get into the a lot here, they can make a maneuver to be here on the left lane while waiting for the oncoming traffic to be clear and have some gap for making a safe movement of left turn. Once the left turning vehicles stay on this lane, the two vehicles will not be blocked by this vehicle. So it's giving the movement along the corridor much better than, just waiting, have the left turn vehicles stay on this road, on this lane. So this is a good way to do it. Yeah. Similarly, you can also make a left turning vehicle at the intersection like this too. So in some part of the urban area, they provide something like island instead of having the instead of just having the typical lane that can get through. Okay, it has some island for pedestrian to cross the road safely too. This is not, yeah. In Thailand, a lot of people that do not understand the uses of this type of design. Okay, many cars use this area as the passing lane, which is not purposely designed for that. Anyone who stands on this pavement area usually get a chance of being hit by those erroneous vehicles. So that's why we need to educate more drivers to use this as a two-way left turn. Okay, no driving on this marking. But the designer, I think they didn't think very clearly when they design this kind of road. They want to save the money or the budget to decide the segment of this road with low cost. A full ultimate design usually have a rest median, okay, in the middle. But to save the cost, we change to this type of design. But after, I think, about 6 years of implementation, nowadays Department of Highways will no longer design the road like this.
อาจารย์ครับอาจารย์แชร์สกรีนยังครับ
Oh, I forgot. You didn't see that. Thank you. I forgot. Okay. Okay, sorry about that. So on this right photo, this is the pavement marking that I talked about. This is what you see on our country. What we call this is เกาะสี okay. ขอพูดเร็วๆแล้วกันนะครับ เรามีการดีไซน์มาแล้วสัก 6-7 ปี และพบว่ามันเป็นอันตราย pavement marking แบบนี้ไม่เหมาะกับการใช้งานบนทางหลวงของประเทศไทย เพราะว่ามีรถมักจะเข้าไปใช้ในลักษณะของการแซงมากกว่าการจอดรอแต่คนที่ยืนอยู่บน pavement marking บริเวณนี้เนี่ยสำหรับการจะข้ามถนนไปเนี่ยส่วนใหญ่จะประสบอันตรายนะครับตอนนี้เลิกใช้ไม่ออกแบบนี้แล้วถนนกว้างกว่าด้วยนะครับทำให้ยิ่งขับเร็วครับโอเค Okay, undivided multi-lane rural highway. Yeah. When we talk in this chapter, as I mentioned earlier, we talked about basic freeway segment and multi-lane highway segment. So the basic freeway section or segment is the segment that's shown as the highlighted area here. The graphic over here is not a flower, okay? It's like interchanges, is represent the interchanges. The graphic here shows the section of on-ramp and off-ramp, okay? You can say this is interchange too, but this denote to an off-ramp, this denote to an on-ramp. Remember, they driving on the right hand side. So get off here, get on here. Okay. These figures 14.2, this figure shows the plot between flow and the speed. And dot lines show the boundary of level of service A, B, C, D, E, and F for basic freeway segment. And the dashed line represent the density. Okay. Last Tuesday, I mentioned about this graph. The table 14.1 represent the equation of the curve in the figure previously. Okay. So, yeah. FFS stand for free flow speed. The The top one is 75 miles per hour. The bottom one is 55 miles per hour. It start breaking point, okay, as free fall speed at 75, breaking point is 1000. That represent this dot line on this column. Okay. After the breaking point to its capacity, which represent from here to here, okay, here to here. This is the equation. Okay. Hope you understand. The other graph, which is figure 14.3, this is for multi-lane highways. Okay. Don't forget the differences between freeway and multi-lane highways. So freeway is totally controlled, but highways, you can have some access from the site to the travel lane. Free fall speed, FFS, quite slightly different from the free fall speed curves for the freeway. Since the red dot is not is the same at the same point here. Okay. Start here, start here, start here. Let's start to drop the speed. Okay. So for speed that is above 1400 passenger car per hour per lane, you can use the equation for precise measurement. Right here, this curve is this one. Okay. Well, because I think on the
ได้ยินไหมเอ่ยฮัลโหลฮัลโหลครับ
okay.
ได้ยินครับ
ได้ยินครับได้ยิน
Okay. So this graphic show the differences between level service A, B, C, D, E, and F. It just gives you the idea of what the level service A look like. A, B, okay. C or D on here. E or F. This one is F. So bumper to bumper. The table 14.2, this one represents the level service criteria for freeway segment. Okay, over here. And this on the right column show the criteria for the multi-lane highway segment. This slide shows the differences between the maximum service flow rate for the basic freeway and the maximum service flow rate for multi-lane highways. Free fall speed at 75 miles per hour. And the level service E, you see, this is 2,400 vehicle. And you can see this is the capacity of the facility that has the free fall speed at 75 miles per hour. at the multi-lane highways. If the free flow speed is 60, the maximum service flow rate or reaching the capacity is 2,200. Okay, just check. Okay. As at this point, is there any questions? Okay. Now we come to the analysis part. For capacity analysis, you need to understand some of the conditions. Okay, the conditions that giving you the maximum speed flow rate and what they are. Okay. For the multi-lane highways, the ideal condition is 12-foot lane with 6-foot lateral clearance. All vehicles are passenger cars with familiar drivers. The free flow speed is 60 miles per hour and the road is divided. No access point at all. The capacity will be sure according to this one. All right. For the basic freeway segment, the ideal condition would include minimum 12 foot lane. Okay, 12-foot lane. The right shoulder lateral clearance of 6 feet. Okay, the right shoulder, so is on, you're driving on the right hand side, right? So มันคือขอบทางด้านขวา but on the median ขอบทางด้านซ้ายจำไว้ว่าขับรถด้านขวาเนาะในอเมริกาตรงเกาะกลาง 2 feet the clearance is 2 feet. Traffic stream consists of passenger cars only, okay. No trucks. In urban areas, it contains 10 or more lanes. Interchanges have the density of interchange would need to be 2 miles or more. Okay, once every 2 miles. You can say 2 miles apart. The longer, the better. The impact of interchange, as you see in here, if we have this interchange close by, if it's less than 2 miles, this section will no longer act as the ideal condition. The road is located on level terrain, not hill, not mountainous. The grade shouldn't be less than 2%. Okay. Driver population dominated by regular and familiar users. So this slide conclude the points of the conditions that we talked about. Okay. Something that you should keep in mind. Okay, the impact of lateral clearance like this when there is no shoulder or clearance of the median would give the drivers the interfere of the objects along the road. They trend to drive slower and away from these objects compared to pavement markings or compared to wider lateral clearance. On the right graphic here, you can see the space between one vehicle to the other. The other is a truck. This is a truck. So if the fleet contains trucks like this, gaps and speed of vehicles in the fleet shall be different. So the large populations of trucks in the fleet would give the impact to the free flow speed. There are three types of analysis. First is operation analysis. Second one is the flow rate analysis. And the third is the design analysis. Okay. So the first one is to determine mostly for the existing condition of facilities. The second one is to kind of plan or wish to have a facility that's served at the desired level of service. For example, if you wish that the facility should accommodate level of service C, how many number of lanes should be here? Okay. But for the design analysis, you definitely need to identify how many lane configurations or the number of lanes according to the design, the directional design Hartley volume, if you know. DDHV. If you know how many vehicles that are going to pass to this stretch of area, how many lanes of the freeways or of the highways should be designed. You may add like 5 years, 10 years, or 20 years, and what the levels of it should be. So that involved with the design analysis. Anyhow, we're gonna go to the details, and then you see the example questions, so you can get more understanding. Okay. According to the this graphic, the analysis of service flow rates and the service forum volume will give you the idea what is see you later. So according to the graphic here on the left here is the correlation of flow and density. This is the density that started from 0 to jam density, right? Over here, this is the jam density, or the area where the speed is low, flow cannot, flow is become 0 too. 0 here and 0 here, right? This is where the flow is 0. So it's congested here. No flow, movement, no movement, no car cannot go. So it's called jam density. Over here, this is the maximum density. I'm sorry. This is the optimal density. Just a second. Okay, so this is the point where the density is optimal. At the peak, this is the maximum flow rate is located. Service flow rate can be identified by multiplying service flow times peak hour factor. You get the service flow rate. Okay. I'm sorry, service volume. Service volume. Okay. This is service flow rate. PHF, peak hour factor, is calculated by the peak hourly volume. Okay, it's the total volume of all here. Okay. Each bar, this is the volume every 15 minutes count. Like last class that I mentioned, if we started from 4 to 4:15, and this one 4:15 to 4:30, this one 4:30 to 4:45, and 4:45 to 5 p.m., for example. The volumes you count may be different. The third column shows the highest peak. Okay, this is the V15 peak. Okay, you use the volume over here at this point times 4. Okay, times 4. So the denominator gonna be higher number. Okay. The peak hourly volume are the total volumes of all flow. So if it's going to be PHF is going to be 1 under the condition where all these okay, is the same, right? The same level. V15 is totally the same on each 4 slot. So the total volume divided by 4 times V15 will be equivalent to 1. If you turn the textbook on page on this page, you can start seeing how they calculate the free fall speed from this graphic. Okay. The question asking here that it is example shown an adjusted demand flow of 1800 passenger car per hour per lane is occurring on the freeway with a free flow speed of 65 miles per hour. For this condition, the expected speed is determined as 62 miles per hour. Why? 18 passenger car per hour per lane right here, right? Going to hit the speed flow curve at free fall 65 free fall speed facility. This is this one. Hitting over here. So it's saying that at 1800 passenger car per hour per lane, the speed is about 62 miles per hour. But if you use the equation, you can identify 62.7 miles per hour. Density can also be calculated once you know the speed. The density is found by the flow rate divided by the speed. Okay, so 1800 divided by 62. So it's giving you 29 passenger car per hour per mile per lane. So it's not beyond 35 passenger car per mile per lane. So it falls into level service D, right? This area. So that is just an explanation of how you calculate the existing condition of the road, which is the first analysis. We may need to go back and forth, okay? But the slide kind of connect to the textbook that I want you to understand. Okay. Let's go back to this is the table 14. Okay. Now we come back to the adjustment for free flow speed on a freeway. Okay. Let's go back here a little bit. Okay. So we are sorry, the question is focused on this part, right? And we were already talked about this part, service flow rate and service volume analysis. And we talked about the design analysis over here. Come to the 14.32, determining the free flow speed right here. The free flow speed of a freeway can be estimated using this equation 14-5. Okay, determining free flow speed, FFS. This equation, if you look at it closely, that means no longer under the prevailing condition, right? If there is some impact of what? Lane width and lateral clearance, okay? And number of interchanges, the free flow speed will be changed. Okay, let's see the first one. Lane width, adjustment for lane width, okay? The best condition for lane width is an average width of 12 feet or greater. Okay. For narrower lane, the base free flow speed is reduced by the factor shown in table 14.5. Okay. If you look at this closely, each foot of reduction make the impact for the reduction of the speed differently. If it's 12 foot, there's no reduction. Yes, of course. 11-foot lane, it's become 1.9 mile per hour lower. But if it's a 10-foot lane, it becomes 6.6 mile per hour lower. Okay. This one is the lateral clearance adjustment. This lateral clearance is 6 feet or greater on the right side and 2 feet on the median. Okay. Adjustment for the right side lateral clearance less than 6 feet are given in this table. There are no adjustment provided for median clearance less than 2 feet. Because it said here such conditions are considered rare. Why they said here is rare? In the past, they may have some condition that giving the median lateral clearance less than 2 feet. But according Federal Highway Administration, they try to make sure that the median clearance is at least 2 feet on everywhere. That's why they started saying this now. But in Thailand, we still have a problem of sections that may have the median lateral clearance less than 2 feet. 2 feet is what? 60 centimeters, right? But anyhow, to use this adjustment, you have to look closely. The left column here says right shoulder lateral clearance, right? The reduction in free flow speed, you look at number of lanes in one direction. You consider 2 lanes in one direction, you look up on this column. If, for example, right shoulder clearance is 4 feet, and the lane configuration is 2 in one direction. So the lateral clearance, the adjustment factor for this gonna be 1.2. The more lanes, the less impact, if you see here. For the TRD, the last part is the total ramp density. The total ramp density is the total number of ramps, on ramps and off ramps within 3 miles of midpoint of study segment, divided by 6 miles. Okay. Ramp density is a surrogate measure of related to the intensity of land use activity in the vicinity of study segment. So if there are many ramps, then the impact of the access to the segment will be increased. Yeah. That is for basic freeway segment. Okay. 14-5 is for basic freeway segment. And you find the free flow speed. However, for multi-lane highway segment, free flow speed can be found using 14-6. Okay, if you see in here, you will look at 4 adjustment factors. The first one is the lane width. The second is the lateral clearance. Third one is the type of median. And the last one is adjustment for access points. Okay. Here, what they talk about best free flow speed. Okay, a best free flow speed of 60 miles per hour may be used for rural and suburban multi-lane highways if no field data are available. But if you go and observe field data, and if the best free flow speed is higher than 60, use the field data. Somehow it may be estimated using the posted speed limit. The best free flow speed is approximately 7 miles per hour higher than the posted speed limit. For example, if the posted the speed limit is 40, okay, the best free flow speed is 47. But if the speed limit is greater than 50 or 55, the best free flow speed is approximately just 5 miles higher. Okay, so there are 2 ranges: 40, 45, 7 miles per hour higher. 50 and 55 would be 5 miles per hour higher. Any questions, guys?
Maybe have.
Okay. For lane width adjustment, it said the best lane width for multi-lane highway is 12, as was the case for freeway. For narrower lanes, the free flow speed is reduced by the values here. 14.5 right here. Okay, they use the same one, 14.5. It's the same for multi-lane highway as for freeway. But for the lateral clearance adjustment, this one, you look at it carefully. Okay? The multi-lane highways adjustment for lateral clearance is based on the total lateral clearance. That means both sides, okay? It's the sum of lateral clearances on the right and on the left. It seems a simple concept, but there are differences here. It said here, a lateral clearance of 6 feet is the best condition. Thus, no right or left side lateral clearance is ever taken to be greater than 6 feet. Even if greater clearance physically exists, the best total clearance is 12 feet, 6 on the right, 6 on the left. For undivided multi-lane highway, undivided, okay, there is no left or median side lateral clearance. However, there is a separate adjustment taken for type of median, including the undivided case. To avoid double counting the impact of an undivided highway, the left or median lateral clearance on undivided highway is assumed to be 6 feet. Should be noted, okay. ตรงนี้ก็คือมันมี adjustment แยกไปต่างหากเนาะดังนั้นก็เลยให้ assume ไปว่าถ้ากรณีที่มันเป็นทางหลวงที่ไม่ได้แบ่งเกาะเนาะไม่มีเกาะก็ให้ assume ว่าเลนซ้ายโทษทีครับไหลทางซ้ายหรือไหลทางที่ติดกับเกาะกลางเนี่ยมีขนาด6 ฟุตเพื่อป้องกันการดับเบิลเข่านะครับ Okay, next, for multi-lane highways with 2-lane left turn lane, the left or median lateral clearance is also taken as 6 feet. For divided multi-lane highway, the left or median side lateral clearance may be based on location of a median barrier. Periodic objects like standard abutment in the median or distance to be the opposing traffic lane. The maximum value is 6 feet. So if you look on the table 14.7, it shows the adjustment here. The total lateral clearance of 4-lane multi-lane highways versus 6-lane multi-lane highways. Total clearance and the reduction right here. Total clearance and the reduction right here. So if you see the 4-lane multi-lane highways definitely has more impact than the 6-lane when the lateral clearance are the same. For example, at 4 is 1.8, right here is 1.7 reduction in mile per hour. If the adjustment, if the road segment is undivided, the reduction is 1.6. Okay, two-way left turn 0, divided 0. This is what they said. Don't double count it. Okay. For the density of the axis, you look at table 14.9. Number of axes in 1 mile: 0, none, 10, 2.5 reduction. If it's over 40, it's 10 reduction. So the impact of urban access would increase in identification of free flow speed. Okay. I believe that the sample problem on this textbook will be a good way for you to look at and start reading it, because I'm gonna use some questions and adapt it in one of your final examinations, but I don't tell you which one. Okay. I want to save your time, so I'm gonna leave you for reading those examples problem. I'm gonna focus on the core of the methodology. Okay, go back to this slide. Okay. The slides, these 2 slides are the conclusions of what I just mentioned. Freeway versus multi-lane highways. So, and the note that you should understand for the total lateral clearance, it even said here page number references. This one is let's go back to the okay. Using a free flow speed curve. Okay, it said here, measure or estimated free flow speed can be used. Result to varies degree of accuracy. So it is generally recommended that free flow speed be measured or predicted nearest to 0.1 mile per hour. Once the result is obtained, appropriate curve in figure 14.2 or 14.3 must be selected. And it's not recommended that analysis interpret a free flow speed curve between those that have been calibrated as part of the methodology. So Yes, if the free fall speed on your left calculated and fall into this category, select the curve according to the one that in figure 14.1 and 14.2. I'm sorry, 14.2 and 14.3. And now we're gonna determine the factor from the heavy vehicles. According to definition, it includes trucks and buses and RVs. Okay, RVs here. It shows that trucks and buses have similar characteristics and are placed in the same category for capacity analysis purposes. Okay. But recreational vehicles are also vary in size and characteristics. Unlike trucks and buses, they are primary commercial vehicles operated by professional drivers. RV mostly private owned and operated by drivers that are not specifically trained in their use. Okay, that means they are regular drivers, like as I mentioned, elders and who already retired and want to drive sightseeing around the country. And the RV generally have a better operating condition than trucks and buses. And they have the power weight to horsepower ratio range to 75 to 100 pounds per horsepower. So in the other term, the RVs are capable than truck and buses. Well, if you were in the US long time, to be able to drive along the freeways or highways, some of you may experience that trucks are very powerful. They are not, like our trucks in Thailand. Their powertrains are a lot powerful. The trucks can be driven very, very fast as regular vehicles or passenger cars in certain areas, such as on freeway. The only notice when I was in the US, what I noticed was when they having the steep grade, and they started showing the differences between passenger cars and semi trucks. Anyway, so what you, as according to traffic engineer, you want to compare the same thing, right? So you want to know one truck is equivalent to how many vehicles, how many passenger car vehicles. So this is what they're talking about. Okay, the heavy vehicle adjustment factor is based on the concept of passenger car equivalent. A passenger equivalent is the number of passenger cars displaced by one truck, or one bus, or one RV in a given traffic stream under prevailing conditions. Okay. Two passenger vehicles equivalent values are identified here. ET stands for passenger cars equivalent for trucks and buses. And ER stands for passenger car equivalent for RVs. Okay. in different countries, this number may be different. Okay. According to what they recommend is here. From field study, okay, in United States indicate that particular traffic speed, each truck displaces 2.5 passenger car, okay, 2.5 passenger car. And RV displaces 2.0 passenger cars. We are not talking about one truck, okay, stay still, and you compare to a still passenger cars when they don't move. Okay, it's not like that. They compare in experiments with capacity on the freeway under the given conditions like that. So saying that one truck is equal to 2.5 passenger cars. Okay. So the number of equivalent passenger cars in the traffic stream is found by multiplying the number of each class of vehicle by its passenger car equivalent. Okay. Noting that the passenger car equivalent of a passenger car is 1. So trucks, if there's a the prevailing traffic stream is 1,000 vehicles, 10% of them is truck. So you can find that there are 250 passenger car equivalent in that traffic stream. For RV, if there are 2% of them, then there are 40 passenger car equivalent in 1 hour. And the rest are cars. Okay, so it's 880 passenger car equivalent. So when you sum the total of passenger car equivalent in 1 hour, is totally 1,170 passenger car per hour. So this is something. Yeah. Traffic stream 1,000, 10% truck, 2% RV. Okay. So you can find the total is 1,170 passenger car equivalent per hour. So then you can calculate the FHV according to the equation 14-7 here. So FHV is equivalent to the total volumes divided by the total of passenger car equivalent. So a heavy vehicle factor is 0.8547. Anyhow, if you're gonna do like that to many segments of the roads, it's gonna be troublesome because you may lack of enough data. So to make it simple, we shall use the 14-9, okay, instead. So you can identify factor for heavy vehicle using this equation instead. So what is PT? PT is percentage of truck or buses. PR is percentage of what? Of recreational vehicle. Okay. ET and ER. Okay. ET and ER, because this one is given, but you can identify from table 14.11 here. The passenger car equivalent for trucks and buses and RVs on extended general terrain section of freeways and or multi-lane highways. So if it's a level, ET is just 1.5, ER is 1.2. But if it's a rolling terrain, the ET becomes 2.5, ER becomes 2. From mountainous area, ET becomes 4.5, ER becomes 4. Anyway, the level terrain is identified according to this definition here. Terrain, lowering, mountainous. Okay. Are there any questions? Okay. Next. For great effect, because on some road segments, the terrain may be not smooth or maybe have a different grades composite, like steep grade, then steep grade connected with the smooth grade for a period of time, for a period of distances, then you may need to use the concept of this one. Okay. Any grade that less than 3%, that is longer than 0.5, or grade or any grade of 3% or steeper that steeper than or steeper and longer than 0.25 must be considered as a specific grade. Okay. So instead of using this, you may have to use table right here. This table 14.12, this is for truck and bus on upgrade. Okay, ET from of upgrade. So if it's less than 2%, it's just 1.5. 2 to 3, and the length of mile is between, different categories here. You need to use the right ET according to the percent of bus and trucks. For example, if there are 20% of truck and buses on grade that 4.5 in the length of 0.75 mile. So I said 20, right? 20% here. Grade is about 4.5. So on this segment, right? So it should be around 2.5. This one. For an upgrade, for an RV, we use this table, 14.13. And for downgrade, we use 14.14. Okay. Composite grade technique. This one is the one that you may get confused because there are several techniques to be used. One is use average grade technique, okay, and the other use composite grade technique. The composite grade technique as described on page 302, okay, with this description. But I found that this graphic is not that clear. So you should go back and refer to the graphic here.
อาจารย์ครับไม่อาจารย์
เหมือนเน็ตอาจารย์หลุด
โอเค มาแล้ว ขอบคุณครับ มายัง ฮัลโหล เน็ตหลุดครับ
ได้ยินแล้ว
ค
ค
รั
รั
บบ ได้ยินแล้วนะครับ โอเค ขอโทษที so yes. Yes, I want you to look at, these pictures rather than the one that on the text because it's not that clear. Okay. But you have to look at side by side. I don't know whether I can make two comparison on the same page. I don't think I can. Just a sec. Okay. Yeah, this part used to describe this part. Okay. Used to describe this part. It's like starting from here, okay? 3,000 feet. Let me read the question first. For composite grade technique, okay, is more exact technique to use. In this procedure, a percent grade of 8,000 feet is found that results in the same final operating speed trucks as composite described. The question is here. Okay. Considering the following composite grade profile, 3,000 feet of 3% upgrade, followed by 5,000 feet of 5% upgrade. So it's two sections, right? The question is, what heavy vehicle equivalent should be used in this case? The first one, the first technique is average grade technique. So the total is 8,000 foot length, right, for the total grade. But it's right 3% on the first 3,000. So it's raised 90 feet, okay. And it's raised 5% on the last segment, which is 5%, 5,000 feet. So it's right 250. The total rise on the composite is 340 feet. Okay. The average grade then be computed by 340 divided by the total, which is 4.25. Okay. So you know that now the G, the grade is 4.25. You go back and open this graph, right? Okay. 4.25 for right here, right? This category for greater than 8,000 feet, which is about 1.52 mile, right? So it's on this side. How many percent truck? What heavy vehicle equivalent should be used, right? It didn't say how many percent in the composite. Just say. Anyhow, is supposed to find the passenger car equivalent from this table 14.12 here when you already have the composite grade, right? Should fall into this category and the length is greater than 1. Okay. We left out, we don't know which composite grade should be, which passenger car equivalent should be used because we don't know the percent trucks and buses right now yet. Okay, but it's along this number. If you if the question give you the answer of which percentage is, so if it's given 10%, 2.5 is the ET. Now, the other technique, said here, composite grade technique, is saying that the curve are entered on exit at 3,000 feet. Okay, the length of the first portion of the grade, this is the first 3,000 feet, intersect with a vertical line construct at this point with 3% grade curve is found. So this is the one. Man, this is not cool. To switch back and forth. So the first 3,000 feet right here meet 3% grade. Okay. Why I know this is the 3% upgrade? Look at, there's a dash and a solid line. The dash line contains minus in front of it. So that means the minus is the downgrade. The plus is the upgrade. So the length in thousands of feet, the first portion is 3,000 feet, right? Meeting 3% grade right here. Go to your left. The speed can be found at 41 miles per hour at the end of first 3,000 feet. Okay. And it's actually the starting point right here. Okay. It's the starting point where the next 5% upgrade shall we start. Okay. So if you know that the 5% upgrade is this line, okay, in this line. At 41 miles per hour, it starts from here, right? Intersect here. And then go a little further for another 5,000 to your right here. So the total is 8,000 feet now, right? So it stopped here. That means at the end of 8,000 feet, the speed of this truck is 27 miles per hour. And what should we use? What ET should we use? So the equivalent length is 1350 plus 500, 5,000. It's 360, 3,350 feet. Okay, right here. Yeah. Right here. 6,350 feet right here. Okay. Go back a little bit. Sorry that we have to go back and forth. A typical truck we travel at 27 miles per hour at the end of the composite grade as described. To find the equivalent grade, the intersection of 27 miles and the length of composite grade is found. This is the solution point indicating the equivalent grade is 5% grade. So come back here. Why is 5%? Because at the same point, 8,000 feet is 5%. So it's not 4.25, right? It's 5%. So this is the right measurement for a composite grade. So you, as a traffic engineer, you may need to consider using the composite grade rather than the average grade. Okay. This one you can go back and read again. Okay. All right, let's a little bit continue to the rest of the presentation. The driver population factors. This one is still said that is not well established. The meaning of driver population factor is the reason of in some areas where the like tourist places, there are people who are not just going there, maybe just once in their lifetime. So these people are, people who never been there or not familiar with the area. So if you think of those who are not familiar, you may hesitating making a left turn or the right turn when you see the sign. But even nowadays, when the tools such as GPS system or Google Maps are available, it's still those who are not really kind of familiar with the area still there. So the values they recommend here is used between 1 to 0.85. Okay, it's never go lower than that. The bottom one is 0.85. 1 means everyone understand, everyone is familiar with the area. Okay. Now we're gonna go to the details a little more on the example. Let's go back to the okay. So another example of great impact is on this page, example 14.5. 14.5, okay. No, it's not just 14.5 about the great impact. Let's start with the sample problem with 14.4. Okay, this one easy. Instead, in a New York City, this is an old freeway. It is a 4-lane freeway with a 10-foot travel lanes. Lateral clearance is 0. Okay, lateral clearance is 0. And the total ram density is 4.5 rams per mile. The terrain is lowering. Roadway has a current peak demand volume of 3,500 vehicles per hour. Peak hour factor PHF is 0.95, and there are no trucks or buses or RV in the traffic stream. Okay, because this road is the parkway, and these types of vehicles are prohibited. The parkways, in the term of parkways in the United States, normally a tollway. So at what level of service will be operated during the peak period of demand? So this question fall into the first category of analysis, existing, right, condition. You can follow the step here. First of all, identify what kind of facility you are looking at. Is this a highway or is it a freeway? Okay. So a parkway, and it said no truck, no bus, no RV. That means it's fully controlled. That means it's a freeway. Identify free fall speed first. Pick up the equation, right? This one. Oops. Then look up the table. It's said here already that which table you should go and look up. It's a 10-foot range, right? 6.6 miles per hour reduction. And about retrocurrent? It's a 4-lane freeways, right? Yeah, 4-lane freeways. So 2 in one direction, and there's no and 0 lateral current, right? So it's reduction to 3.6. The number of ramp is 4.5 ramps per mile. Then the free fall speed can be calculated to 53.8 miles per hour. Because this free fall speed lies between 52.5 to 57.5 miles per hour. Look up table 1410. So it's fall into which category? Fall into this, right? We use 55 miles per hour speed flow curve to represent base condition. The next step, identify demand flow rate. Under equation 14/1, we can identify demand flow rate as VP right here. While V is the total volume, which is 3,500. PHF identified already is 0.95. N, number of lanes. FHV, no truck bus, so it's 1. FP is 1 because it's in the city. Assume that everyone is familiar. So VP is identified as 1,842 passenger car per hour per lane. The next step is find the level of service and the speed and density. According to step 2, we know that the demand flow is 1,842 vehicles per hour. To enter 55 miles per hour free fall speed curve in figure 4.2. About here, right? Free fall speed is 55. So right here, that means hitting here. Level of service D, right? It can be seen as the level of service for freeway is D, or just barely missing level of service E. Yeah, that's it. Density can be identified here. You know the speed. You divide using the this volume E divided by the speed can define the density. Mhm. Instead of using this graphic, you can directly identify by this number, and if it's fall into table table which it fall into which column of the table 14.2, then you can identify right away whether it's a level service D or E. Analysis. Next one, analysis of multi-lane highway segment. Now this is one highway, right? A 4-lane multi-lane highway section with a full median with 2,600 vehicle per hour in heaviest direction during peak hour. 12% truck, 2% RV in the traffic stream. Motorists are primary lateral user. That means it's equivalent to 1, right? The section under studying is on 3% sustained grade for 1 mile in length. Even the PHF 0.88. You got the field study of the 55 mile per hour speed limit, speed. The question is, what is the level service for this facility during the peak hour? Step by step, you find the accurate demand for rate first under the base condition. So use the equation and then put the number in. The big V is 2600, right? PHF given. N is 2, FP is 1. We don't know FHV yet, so but FHV can be identified by using the equation 14.9, right? But you need to look up the right ET and the right ER, right? This one is pointing to ET to 1.5 by looked up the table 14.12, given 2 to 3% just in 1 mile, right? Of 12% truck. So ET table 14.12, go back to table 14.12. How many truck again? 12, right? 12% truck. Okay, 2.3. So it's fine to these two groups, right? You can interpret 2 to 3. This category don't need to interpret because it's the same number. Oops. Uh-oh. Okay. You just look up to the right table. That's gonna be fine. Oh, I'm sorry, I went too fast. Okay. ER. Now you look up the right table, 1413 for the upgrade. 2% vehicles, RV, and you get the ER equivalent to 3. Now you can find the FHV, which is 0.909. Now you can find BP, which is 1,625 passenger car per hour per lane. That is for the upgrade. That is for upgrade, right? Upgrade. Downgrade, another one. Okay. Don't forget that there's two directions. One upgrade, the other one must be downgrade. So look up for the right ET and ER. Then you can find FHV, which is 0.94. The VP is equivalent to 1572 passenger car per hour per lane. Next is find the level service and the speed and the density. Okay. Look up the equation properly because this is a highway, right? So density up and density down, you can found to be 30.1 and 29.1 respectively. And if you look up from the table, it's also easy to use too. So pick up the right FFS, right? Yeah, it's given 55. FFS is 55. 55, which is this right. So meeting over here. So his level of service D. Okay. You should go a little bit further to the rest of the example. Because yeah, until this example 14.7. It's not hard, it's just different analysis for design, because the first two one is for analysis for existing condition. This one for design application. This one is for the service flow rates. Okay. Remember, there are three categories: the assessing operation, finding the service flow rate, and the service volume, and the design implementation, design application. Yeah, please look up on these examples again by yourselves. Okay, it's self-explained. It's not hard at all. And if you have any questions, you can write me something or call me. I'm gonna stop over here and check you guys names before we leave. Okay, anyway, I'll tell you more a little bit of the how we test, right? I'm gonna stop sharing.
โอเคครับ
Because it's an online test, and I know that you guys have lots of work to do. It's gonna be an open, of course, open book, open notes, whatever you want to see. However, I will have like different types of questions, like fill in the blank, choices, and calculations. I know that calculations are, something that you recently learned. Maybe a little bit on the alignment on the really first session that I taught. I want to maybe questions a little bit slightly different from other professors that taught you, because I'm gonna let you give the ideas much more than remembering things. Of course, open book, open notes requires something that kind of open questions. Get your reasons, get your backup on individually. That means I hope you are not copying each one answers. I hope that you got your own answers. I don't expect that you guys kind of having the same answer to me, okay? And it's not going to be hard for you guys. Go back to several sessions that I mentioned from the video clip, something like that. I want to make sure that you really listen to the focus or the point of those clips. And yeah, I think that's about it. I hope it's not too open for you. I think I already give you some focus, but yes, definitely the questions will be quite open and require your ideas. Okay. Any questions, you guys? It's just in about less than a week, right? On Fridays. Okay. Can you guys turn on the video? I need to record you guys. Thank you.
Okay. Look at this.
I need to use the
Look at this.
That's it.
อาจารย์อันนี้คือค่าสุดท้ายของเราแล้วใช่ไหมครับ
ใช่ครับใช่ครับ
สักครู่นะครับ
เอาแต่ดีเช็คชื่อก่อน
Is this the final exam?
Next Friday.
So today, so let's get ready.
They need to go back and study a little, and then they're gonna have the
And
exam.
prepare to meet their doom.
No.
Yes, right. Okay, I'll let some pass.
Come on.
But I'll let the tricky ones pass and let the easy one you know.
Let me turn this on. โอเคครับเปิดกล้องหรือยังทุกคน
ยังเลยมันไม่กดกล้องเลยอะวอลเดอร์วิว
ไม่ต้องกลัวนะครับข้อสอบไม่ยาก
ข้อสอบง่าย
อืม
คือมันจะประมาณไหนครับไม่ยากเนี่ย
ก็ Open Book Open Notes ไง ใช้ไอเดียตอบจากความเข้าใจเนาะผมไม่ถามคำถามที่ให้เป็นความจำอยู่แล้วมันstraight forward เกินไปแต่จะเป็นคำถามที่จะถามความเห็นแล้วก็ calculation ก็คล้ายๆตัวอย่างเนอะเอางี้ละกันไม่ยากครับ
คือcalculation เนี่ยเอาเรื่องแรกที่เราเรียนไอ้เรื่องวันนี้นี่ไม่เกี่ยวใช่ไหมครับไม่นับ
วันนี้ด้วยครับวันนี้ด้วยรีบกลับไปอ่าน example แล้วกันแล้วก็คลิปต่างๆที่ให้ดูอะครับส่วน PowerPoint ต่างๆนั่นนะคือ reading มันก็ทำให้คุณทบทวนได้เร็วอะว่าที่ผ่านมาเรียนอะไรไปผมมักจะบอกซ้ำๆเนาะเรื่อง safety เนาะทางแยกเนาะอะไรเป็นปัจจัยต่างๆพวกนี้เนาะเรื่องของ traffic calming เนาะเรื่องของดีไซน์ที่ทำให้ urban area มันปลอดภัยเนอะอย่างเงี้ยพวกเนี้ยงั้นจะถามจากความเข้าใจนะที่คุณมีต่อคลาสโอเคขออนุญาตถามนะครับเศรษฐโรจน์มาไหม
มาครับอาจารย์
โอเคครับศิลา
มาครับ
ขอบคุณครับนัทธนิต
มาครับ
ขอบคุณครับกันพิเศษ
มาครับ
ขอบคุณครับปรมาพร
มาค่ะ
ขอบคุณครับศิวพร
มาครับผม
ขอบคุณครับจุลจิต
มาครับ
ขอบคุณครับพิชยะ
มาครับ
ขอบคุณครับชยกฤษ
มาครับ
ขอบคุณครับปิติชัย สิทธิพล
มาครับ
ขอบคุณครับธนพล
มาครับ
ครับวัชรฤทธิ์
มาครับ
วริศรา
มาค่ะ
ขอบคุณครับฮารุณา
มาค่ะอาจารย์
ธัญชน
มาค่ะ
ขอบคุณครับวัชรพล
มาครับ
ขอบคุณครับณัฐพัฒน์
มาครับ
ขอบคุณครับพิชพัฒน์
มาค่ะ มาค่ะ
โอเคครับขอบคุณครับพานุพงศ์
มาครับอาจารย์
ภพพรส
มาครับ
ขอบคุณครับสัญญพงศ์
มาครับ
ซิมิลัน
มาครับ
ขอบคุณครับ สุกฤตสุกฤตห้วน
มาครับ
โอเคครับ สาริยา สาริยา สาริยาโอเค
วัชรพลอาจารย์เรียกไปยังครับเนี่ย
วัชรพล
เรียกไปแล้ว
เรียกไปแล้วครับ
ครับ
เดี๋ยวนะ
เรียกแล้วครับ เดี๋ยวนะโทโท23 มี24 หายไปไหนแล้ว คนหนึ่งเอ๊ะทำไม มี23ในนี้อะจริงๆต้อง24สินะเขาได้23ในห้องนี้เหลือ22
ขาดใครนะครับขาดสาริยาแล้วครับ
เดี๋ยวนะ
เขาไปห้องน้ำหรือเปล่าครับ
ในนี้มี23รวมผมเนาะมัน22มันเกินเลยดิเมื่อกี้มีคนถูกนับไปด้วยคนหนึ่งในนี้ ขออนุญาตถามอีกทีนะครับ เศรษฐโรจน์อยู่ไหมครับ เศรษฐโรจน์
เขาน่าจะออกไปแล้วนะคะ เมื่อกี้เขาเช็คชื่อแล้วก็ออกไปเลย
อ๋อ
ค่ะ
ชื่อเราออกไปเลยใช่ไหมคนนี้
ใช่ค่ะ
โอเคอ่ะได้ครับโอเค เดี๋ยวผมส่งmeeting ที่ record ให้นะครับ อีกทีหนึ่งหลังจากที่นั่นก็ขอบคุณนะครับที่วันนี้มาเรียนแล้วก็ตั้งใจฟัง แล้วก็ขอให้โชคดีในการสอบทุกท่านนะครับ ก็มีคะแนนattention แล้วก็ homework ด้วยนะครับ ที่คุณจะได้เพิ่มอยู่นะครับ ก็ขอให้ทุกคนโชคดีครับ โอเคเนาะสวัสดีครับทุกคน
สวัสดีครับ
สวัสดีครับ
ค่ะ
สวัสดีครับ